Some universes are born from fire, some from divine breath, and some from 4 lines of logic written on a piece of paper. Imagine a world where simple rules birth infinite complexity, where patterns become organisms, where organisms become societies, and where those societies never learned they were created. What if I told you that might be us? Today, we explore a grid, a game, and a theory that suggests reality itself runs on rules. This is the story of Conway's game of life and the simulation hypothesis. Let's begin with the simplest universe ever built. In 1970, mathematician John Conway wasn't trying to prove reality was code. He just wanted a puzzle, something elegant, minimalistic. He took a blank grid, squares, alive or dead, nothing more. Then he defined 4 rules. 1. Any living cell with fewer than 2 neighbors dies, loneliness. 2. Any with 2 or 3 neighbors survives, balance. 3. More than 3 dies, overcrowding. 4. A dead cell with exactly 3 neighbors becomes alive, creation. 4 rules. No dice, no randomness, no player. Yet when the simulation runs, chaos blossoms into order. Cities of digital life expand. Colonies build highways of moving structures called gliders. Some patterns become guns, endlessly firing new cells. Others become immortal loops. There are even patterns that construct other patterns. Evolution born from logic. Death emerging from arithmetic. Creation encoded in mathematics. And somewhere in those patterns, something that feels like life. Strange, right? Programmers couldn't stop staring at this grid, not because it was beautiful, but because it was familiar. Conway's world acted like biology. Organisms adapted. They competed for space. Some thrived, others went extinct. And none of this was designed. It emerged. Rules, patterns, patterns, behavior, behavior, strategy, from nothing but logic. This was the first time humanity watched evolution, not over millions of years, but in milliseconds on a monitor. Talk about fast-forwarding natural selection. Scientists began building enormous game-of-life worlds, watching empires rise and fall on a grid smaller than a checkerboard. But the real shock came later. Researchers proved the game of life is Turing complete, meaning, with enough time and space, Conway's tiny universe could perform any computation your laptop can. Yes, inside those squares, in theory, you could simulate another game of life, inside another one, inside another. Inception, with pixels. Now the unsettling part. If complexity emerges from simple rules, how simple could the rules of our universe be? Physics is whispering clues. Space isn't smooth, it's pixelated, like a grid. Time doesn't flow, it ticks. Reality behaves like information. Matter acts like stored data. Energy behaves like processing. Even black holes, our universe's most terrifying objects, are described by bits of information encoded on their surface. Some physicists joke that the universe looks less like a grand divine painting and more like the output of a very elegant compression algorithm. Elon Musk once said, "There's a 1 in billions chance we're not living in a simulation." He may have been exaggerating, or maybe he read Conway. Simulations have limits. Games have rules that cannot be broken. Our universe has those too. Speed limit of light. Nothing can go faster. Quantum randomness. Values unknown until observed, like unrendered assets. Cosmic expansion. Space stretching like an engine offloading memory. Planck length and Planck time. Smallest units, like pixels and frames. If reality were continuous, infinite detail, you couldn't simulate it without infinite resources. But if reality has resolution, if space-time has frame rate, then simulation becomes not only possible, but efficient. And programmers love efficiency. Here's where things get quite existential. Inside Conway's game, a glider, one of the moving patterns, might think it's traveling by choice. It leans right, it leans left, it navigates obstacles. But it cannot know the rule behind its motion. It cannot step outside the grid. It cannot rewrite the code that birthed it. Sound familiar? We are bound by physics. We cannot step outside time. We cannot stop aging. We cannot change the constants of nature. We behave as if we have free will, yet we operate inside constraints we never agreed to, just like Conway's creations. This doesn't prove we're simulated, but it raises a philosophical itch. If consciousness can emerge from neurons, and neurons are just electrical patterns, and patterns can emerge from simple rules, then perhaps the line between biology and computation is thinner than we once believed. Maybe consciousness isn't magic. Maybe it's mathematics wearing a biological suit. Let's flip the perspective. If Conway's 4 rules created a universe, what rules are we running on? If we are simulations, conscious patterns on a cosmic grid, then the question isn't whether the simulation is real. The question is, will the beings we create someday ask the same thing? AI models that dream, draw, write, strategize are emerging now. Digital ecosystems evolve on servers by the millions. We are becoming the architects of worlds that think. So maybe we aren't NPCs. Maybe we are the gliders, moving through rules we don't yet understand. And just as our patterns grow more complex, what new universes will we create? Maybe one day, our own simulations will look up at their sky, binary stars painted in code, and ask the same impossible question: are we real? And maybe we'll whisper back, as real as we are. In the end, Conway's Game of Life reminds us that complexity doesn't need chaos, just rules and time. From a simple grid of squares, we watched life form, evolve, and collide, almost like a miniature universe learning to breathe. Whether it's a game, a metaphor, or a hint at our reality, the mystery keeps unfolding with every generation. If you want to experiment with the code or create your own universe, the full project is available on GitHub. Oh, and if you enjoyed this journey, don't forget to like the video and subscribe for more mind-bending science, simulations, and strange ideas. It helps the algorithm keep this universe alive.